If you want to learn how to draw the sine curve, the cosine curve and the tangent curve swiftly and effectively, then you've come to the right place. G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm your host, Graham Henderson. In my opinion, being able to draw your sine curve, cosine curve or tangent curve rapidly provides a very useful tool for answering a lot of questions in trigonometry. I'm going to show you how, and the challenge is for you to learn to draw each of these curves in about 20 seconds. I've found that it's quite possible to do that. It might take you a few nights of practice, but just time yourself. I'm going to draw the sine curve first. It will take me a little longer than 20 seconds because I'll talk at the same time. But let's see. With all three of those graphs, we draw the two axes. We label the vertical one from +1 to -1. And the horizontal one we mark with 4 extra marks for 90 degrees, 180 degrees, 270 degrees, 360 degrees, and mark it with x or theta, whichever the variable is going to be. If, by the way, you're learning radians, simply label these pi on 2, 2 pi on 2, which is just pi, 3 pi on 2, and 4 pi on 2, which happens to be 2 pi. Either of these, I wouldn't do them both at the same time. I'm going to leave it with degrees because I suspect that most students out there will be more familiar with them. Now for the sine curve, the vertical axis will be sine x. The sine curve starts here and goes to there and there, level with -1 at 270 degrees and back up, and it looks something like that. It should have gone through that point. That whole process should have taken you about 20 seconds. What are some of the benefits? Well, I think you can see that, for example, that sine of 10 degrees will be the same as sine of 180 minus 10, or 170 degrees. Or it would be the opposite of 180 plus 10, which is 190 degrees, or the opposite of 350 degrees. And you can check that on your calculator. That sine 350 degrees is minus sine 10. The same size, just opposite in sign. We'll talk more about that later. But there's your sine curve. Now I'm going to erase this and do the cosine curve next. So here's the cosine curve. Same vertical axis, same horizontal axis. From 1, 0 to -1. We'll call it x again, the variable. 1, 2, 3, 4 points. 90 degrees, 180 degrees, 270 degrees, 360 degrees. The cosine curve starts at 1. I think of it as a Big Dipper, like you might have in a theme park. So it goes from 1 down through 0 to -1 and back up through 0 to +1. A very simple curve. It's basically, well, it is exactly the same shape as the sine curve, but just shifted back 90 degrees. We call that a phase shift in physics. But there it is. Learn to do that one in 20 seconds. Now for the tangent curve. We start off in exactly the same way. One, 0, -1. Our 4 points, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Do pardon me, that was very badly written. There we go. Now, the tangent curve has asymptotes at 90 degrees and 270 degrees. Every odd position, the first line, the third line, the fifth line, and so forth. You can think of it as that's odd. The halfway mark, which is 45 degrees, has a tangent of 1. The same will apply here, tangent of 1. The halfway mark here will have a tangent of -1, and the halfway mark will have a tangent of -1. And the tangent will come asymptotically down here and through 0. It will come down through 0 and through there and through there. And there's your tangent curve. It's very, very useful to be able to draw that in about 20 seconds as well. Because of the asymptotes and the extra points, it may take you as much as 25 seconds. But learn to time yourself and graph it. Here you can see that the tangent, for example, of 10 degrees is the same as the tangent of 190 degrees. That is 10 degrees above the 180 position. Or it's the opposite of tan 350 or tan 170. That is coming back 10 degrees. It's very handy to be able to note that. The next thing I'm going to do is draw the sine and cosine curves together and show you how they relate. So do watch this. Now you can time me. I'm still going to be talking, but I hope to do this a bit faster. So here goes. 1, 0, -1, 1, 2, 3, 4, 90 degrees, 180 degrees, 270 degrees, 360 degrees. There, 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 and there. And there's our sine curve. I'll call that sine x. Drawing the cosine curve underneath it from 1, 0 to -1. 1, 2, 3, 4, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Cosine's the Big Dipper, like so. Goes down through there, up through there, and both of them are now graphed. I will label this cos x. And I truly and honestly encourage you to practice drawing these rapidly. To have these on a scrap piece of paper or the top of a sheet of paper in your exams is tremendously useful. For example, if I asked you what's the cosine of 80 degrees, I hope you can see that's the same as the cosine of 280. That is, instead of coming 10 degrees below 90, we can go 10 degrees above 270. But if you shift to the sine curve, which is the same shape, I hope you see that it will be the same as sine of 170 or sine of 10. If you ask me what was sine 100 degrees, which is 90 plus 10, sine of 100 degrees will be the same as sine 80. And down on this curve, it will be the same as cos 10 or cos 350. So using your graphs to see these relationships can be enormously useful. I'm not really going to comment anymore at this stage. I'll comment on these curves in other videos, but the reason I wanted to share it in this video is to encourage you to learn to graph those 3 graphs in about 20 seconds each, and to make that so much a part of your understanding of trigonometry that you'll find it will be a tremendous benefit to you. Thank you for watching. Please subscribe, like and comment on this video. Thank you.